we have this public method. So a very simplest of the reduce. These are overloaded methods. Both of these methods are overloaded. The simplest form of reduce, it's a method on a stream of t. So this one will return t. And the one which you are looking at here, the method name is reduce. And the parameter will be two parameters. One is a parameter of type t. Right? So this is like the, what we can say, this is my initial or something. Okay, and you have a unary operator of t. Not unary, it should be binary operator. So want to understand what is this, because based on this the other advanced terminal operations also are similar. I mean a similar kind of a thing, very close to each other. And what is being done here? Okay, to understand this, and I'll just take a small example. Okay, I'll first thing, suppose I ask you, fine, all of you would have done this as a simple programming exercise. Given an array, okay, find the sum of elements in the array. How do we go about it? Given an array, find the sum of elements in an array. And that is what is to be returned by us. Yeah. How would you do it? Okay. So see the things which are involved here to find the sum of elements in an array. Yeah. What are the things involved? Look at what we are doing normally. We will say, okay, let me start with the int. The type is int, let's assume, right? It's an integer array. So I'll say int, yeah. Initial value, I'll say, you have assumed some value for the sum equal to 0. Yeah, I get the name. Here, this is actually known as identity. So this is your 0 is the identity here. Okay, and then use a for loop for each int a in whatever that array would have been. Yeah. So that's fine. We have to iterate over all the elements. We have to process all the elements in the string. We'll see. We actually will be dealing with string on a similar line. But then what is being done here? Then we'll say sum equal to sum plus a, the element from the next element. Right? And then whatever happens, let me now return the value of the sum. And this is the code we write. Okay, 0 is the identity. And add, fine, is the binary operator. It gives this, so it has parameterized what is the identity and what is the operation you want to perform. And explain this. And what has got parameterized is the, see, you're passing, okay, that's, instead of saying plus, it's being passed as a parameter. It's like you're passing a parameter, it says, what is it that I should do here, right? Okay. Okay, let me now talk in terms of the type T. See, I start with type T, okay, and result equals identity. This is my initial result which I have assumed, right? Because I have I have not yet processed any elements. Right? And then I'm saying, okay, for each type T, find the value which comes from the array. Okay, I'm assuming an array or whatever it is. Instead of array, you should assume it's a string there. And the next element from the string. And what I should be doing here, result is equal to, I have that, what we call it as, what was the variable name? We said it is called OP. It says OP dot, it's a binary operator. So the method name is apply. In apply, what should be passed as parameters? The previous result and the value, next value. And then it says, okay, let's return the result. See, such a thing is to be done. And what we have done is we have said, okay, this is like a template. You can think this is like a template. Okay. So when we use that method called reduce, we are passing, this is to be used as identity in this kind of a template. I'm passing the identity, I'm passing the operator. I'm passing a binary operator. And you process and give me the result from it. Fine. Okay, one more thing. What is being done here is may not exactly be the way I have put it here. Okay, some more optimizations may have been done. This is how we look at it normally, but yes, if you look at it in this manner, then it's exactly like, yes, as if you are doing it in this manner. Okay, so when you call the reduce method, okay, so when you call the reduce method, this is what it should be doing, equivalent of this. And this particular form of reduce method. Fine, clear? Okay. Now I'll tell you one more overloaded form of the reduce. So this is one kind of a reduce, but from this we can understand the next reduce also. If you have understood, fine. Is this reduce clear or any questions? I'll explain again. Okay. Okay, let's see it here like this. Okay, so what reduce is doing? What have we passed as parameters? Identity. We say two parameters, right, in the reduce method. First is the identity, which you consider as the initial result. It has assumed this is my initial result, and I have to update that result by processing it with the elements from the string. Okay, so it's like this. There are so we start with identity. So this is my identity object. Okay, and fine, if there are elements in the string, this is my whatever is the identity, that actually is my result initially. That's my assumed result. And then what happens is we pick up the element from the first element from the string. Let's say this is, because it's of type T1, let me call it as T1. Type is T, let me call this is an element of type T1. It uses a function which is the binary operator, fine, where these two are the input and it results in an output. And whatever is the output generated by processing with the first element is then again used with the second element from the stream and passing given as input to the function, which is this is your binary operator. Okay, and same binary operator used again. It's a function basically, same function, binary operator, right? Fine, with this one, and that would result in an output. So like this, keep on processing and you get a final output. This is exactly what you were doing when you were writing the code for finding the sum. Okay. Right? It has just parameterized it, right? Initial result we say is 0, process every element, just add them, add is my binary operator.
Using all the elements to one.
To single. Yes.
After some kind of computation or some calculation.
Whatever that binary operator. So you are passing that, what it should be done. Given the previous result and the next element, how do I merge them and create a new value for the result?
And will be just one value.
One value. At the end, you get one value. Okay, how about splitting the entire set of values and doing some parallel processing? Oh, that is also likely, right? It will increase my speed. I can have a better processing if I can split my, so instead of finding the sum by sequentially going through every element, let me break, I have got thousands of values. Let me break it up into smaller parts and I can compute the sum for each of them separately. So then I will have multiple sums. Then what I'll need additionally? I'll need a combiner to combine those intermediate results, partial results. I'll say for each part. So there is a part result, right? You can say, and if I can split it, okay, so it's like one splitting. So similar thing would have been done for starting with the same identity. Everyone starts with the same identity. Okay, fine. So there is another, this is one part, this is another part. Identity is used as the same, but another set of elements. So this is from part 1, right? So this is, let me say T11, T12, okay? So from part 1, first element, from part 1, second element. Same way, here I have T21, okay, fine. Applying the same function, which is taking 2 inputs and resulting in a output here, okay, and then that's applied with another T22, I put it like this way, okay, fine. And that's going as input to a right, fine. But if I'm generating, then I'm having one partial result here, that's my one result, that's my second result, and same way there might be more results, right? So what I will need further is to combine all of them. We call it as a combiner. We'll call it as a combiner. So what is the input to a combiner? Two elements of this type, whatever the type may be. I'll come to that type thing again. Okay, so two elements of the combiner, and if I know how to combine two elements, I'll be able to combine multiple elements. So that's going to be a binary operator again. But one thing now, what we can do here is we can change the result type. See, I'll just give an example where finally when you want to process, the final output is not to be the same type. The result type need not match the type of elements in the stream. If you are finding average, right, your result type is double. Your input type was int. I'm just giving example where the result type is not about being same as the type of the elements in the stream. So we are saying we are processing elements of type T. It's a stream of T. But my result will be a different type. So here, this identity is of type U. The elements are of type T. Identity is of type U. What we need here instead of a binary operator would be a bifunction. Fine. Where the input is of type U, second input will be of T, two inputs, and the result will be of type U. So instead of a binary operator, more general one, saying yes, my result is not the type of the elements. My result is a different type. So start with the initial result. Fine. Have a function which takes that result and the element from the stream comes up with a new result. It will be of type U now. Fine. And so here what we need is a binary operator of U. The combiner is a binary operator of U. So now I can write the next method, right? I was explaining the method, the mechanism first, but now you can have a look at that method, right? So the second form of, so this is the second form of, one more form of reduce. It has a type parameter U now and returns the value of type U. That's the result. U is the result type. Elements to be processed are of type T. Name of the method is reduce. Parameter will be U, which is the identity. Second parameter will be a bifunction of U, T, T, U. Okay. Fine, that's your bifunction, right? Fine. The previous result, the next element from the stream returns a new result. Right? Bifunction takes two input and returns, right? Find those first two parameter type. Right? So that's your function. Okay, and third, this we call as, the term used here is accumulator, because that's what is doing the accumulation for me. Okay, even here I should have just said instead of operator, I'll just use the term here. This is my accumulator. When accumulate, using this I accumulate the values on the stream. Okay, so here it has three parameters, accumulator, and what's the third one? Combiner, right? So combiner is of type, yeah, binary operator of U. Okay, that's a combiner. Fine. Okay, clear. So it goes through a similar exercise as the earlier case, but after that it is generating basically, like you can understand, there is a splitterator which can be there. So splitterator is used for splitting it into smaller parts, and each part fetch the result, generate a result for each part, and then for the generated partial results, these are all partial results, it has to combine them. For that I have a combiner. And the reduce method. Okay, one more form of reduce is there. Okay, which is okay, it doesn't involve a new type here, right? So it's going to return an optional of T. Okay, name of the method is reduce. It's a reduce method overloaded, and the parameter is, no, we are not passing identity, we are not coming up with the initial result, but we are using a binary operator of T. So that's the accumulator only. So you're only passing the accumulator. Okay. So when you pass only the accumulator, then what it has to do? You have not specified the initial result. It uses the first element as the initial result and carries out a similar activity. See, for example, if you have to find the minimum, how do you go about it? First element is picked up and then compared with the others. Okay, right? So just that way. So in that case, if it is empty, I have to return a empty. So that's why it's like this reduce method is not taking an initial, there's no identity here, only the accumulator is given. So fine, so three forms of reduce. Okay, three forms of reduce, and okay, there are two forms of a method called collect. Okay, there's a method called collect and it has been overloaded. So yeah, let's see. Okay. I'll put the method signature maybe here. Fine. I don't want to discuss it right now. Okay. And you need to and be able to accumulate whatever is done here, right? Anyway, so this takes, it's a public method and returns the result R. Okay, it's going to return the result R. Okay, name of the method is, so okay, there's a type parameter R here. Okay, name of the method is collect, where the parameter, okay, this one, instead of an identity as a fixed value, uses a supplier to get the initial value. Okay, so there is a supplier of type R. Okay, fine. Now instead of a function which returns two inputs and returns a value, here it is a consumer which is available. It consumes the two things. So it's a buy consumer. Your accumulation is done by a buy consumer of R, T. The object which is initially supplied by the supplier, okay, which is made available by the supplier, is reused again and again with every element of the string. This is our accumulator. Okay. There is a third parameter. Let me put, I think each parameter I can put in a separate line. Okay. Fine. So we have an accumulator, then we have a, yeah, what else would be needed? Combiner, because yes, it can be done in parts also. So we have a, the combiner here is going to be a buy consumer of R. Okay, because R is my result type. So this is one form of collect, but the important one and the more useful thing is going to be the other collect method, which takes as parameter a collector of T, A, R. A and R, that's your collector. So it's taking a collector as a parameter, and we'll need to understand what is a collector. Okay, for this we'll need to also understand what is a collector. Okay, collector has got three type parameters, T, A, comma R. Collector of TAR. T, what is T? The type of elements which are to be processed. What is A? We call it as the accumulator type. And R is the result type. So return type is going to be R. Okay, fine. We'll discuss it. This one will be discussed tomorrow only. Okay, but today let me show some examples. Okay,